Hey, good morning. Welcome to VSPG. Today, let's see. Today we have a presentation by Lenka Baratoux and Paul Antonio, titled Mafic Dyke Swarms of the West African and Amazonian Cratons, Petrography, Geochemistry, Geochronology, and Paleogeographic Reconstructions. Next week, we'll have a presentation from Margaret Lantink from the University of Wisconsin-Madison, and title is still to be determined. So I will reach out to Margaret again and send out that announcement tomorrow. I don't have more announcements. Lenka, feel free to set your presentation up, and Andre is going to introduce you for us today. So go ahead, Andre.
Yeah, it's a pleasure to introduce Lenka Baratoux, and she is doing this presentation with a number of co-authors, and specifically Paul Antonio sort of was involved in this work, and unfortunately he is doing field work in Morocco and cannot attend. So Lenka will talk about connections between West Africa and Amazonian Craton in Paleoproterozoic sort of Amazonian Craton and West African Craton, as well as South Francisco and Congo Craton assembled together and formed the core of Nuna Craton. But later history sort of where migration together and partial or complete separation and breakup poorly constrained. And so I presume she will touch on these topics. Lenka is originally from Czech Republic. She did a PhD between University in Czech Republic, Charles University, and University of Lyon. And she worked in West Africa since 2006. She is now a research associate at the French National Research Institute for Sustainable Development. She is based in Abidjan in Côte d'Ivoire, and her interest in Precambrian geodynamics and the relationship between tectonic evolution and mineral forming processes. And she use multidisciplinary approach based on structural analysis, using field data and geophysical data interpretation, thermodynamical modeling, geochronology, and geochemistry. She worked for a number of years as a part of the West African Exploration Initiative that was funded by a number of mining companies and now in fourth phase. And through this work, she sort of obtained samples and dated number of mafic dyke swarms, which she will use to put some constraint on Precambrian paleogeography. So with this, I pass it to Lenka.
Thank you very much. So hello, everybody. It's really a great pleasure for me to present to you today this talk on dikes. As it was mentioned, it represents the work of a huge group of collaborators, which we have started to work with in about 2007, and many of these samples that I will show you were collected thanks to the WAXI project, which actually studies the basement, the Paleoproterozoic and Archean basement. And this project started to be kind of a byproduct or parallel project, and it just became a research project on its own during time with many interesting results. So why is it interesting and important to study the dyke swarms and cells? They form part of large igneous provinces, and they cover huge surfaces, sometimes up to millions of kilometers square. They can have various forms of either radiating or circumferential patterns. and they may have different origins. Quite often they are plume related, but some authors, they describe also plate tectonic setting. And what's really interesting, they are in place during short time periods, which is now very well constrained by the UPB Badeleite ages. And therefore, they can be used as tracers for reconstructions of paleocontinents, and in particular, the very old supercontinents. And of course, if the ages are coupled with the geochronological data, it's of course much better. We can use therefore either method just of barcodes or even the paleomagnetic data. And last but not least, some of the dikes are really economically significant. There are some major metal deposits related to them. So in West Africa, most of the work, like we have much better results from West Africa, but we also have some samples from Amazonian cratons, much less, but I will present them too, and hopefully in future we will have more done in South America too. So first of all, I will present you the mapping of the dikes. So we have used airborne magnetic data and field mapping, then petrography, geochemistry of these rocks, so bulk rocks analysis and analysis. We have done geochronology, so Badeleite dating and UPB dating. And in literature, there also exists argon and potassium-argon dating. But finally, when we compare it to the UPB dating, we had to discard almost all ages except for the camp ages because they were just wrong. And finally, the paleogeography using the barcode reconstructions and paleomagnetic studies. And yeah, a short word on exploration potential. So first of all, when we have first started to study these dikes, it was in Burkina Faso. And then we have extended the study to mostly the southern and northern part of the West African Craton using the magnetic data. So in Burkina, we have noticed quite quickly that these dikes, they are very well visible in airborne magnetic data. You can see them as these sharp anomalies. And this is because of the composition of these dikes. Most of them, they contain highly magnetic minerals like magnetite or ilmenite or titan magnetite. And I will just show you an example of how we have proceeded. So this is Burkina. So we have Taudani Basin, which is approximately 1,000 million years old. And it covers the Birimian basement, the Paleoproterozoic basement, which is approximately 2.1 billion years old. And then we have younger Volta Basin. So you can see here, this is a quite simple example. There is one swarm which is northwest oriented here in the Paleoproterozoic basement, these dikes. Here in northeast Burkina Faso. Now, when we move to the central Burkina, we do see two different orientations. So the question is, do they have the same ages? Is it just some local variation of orientation, or do they have different ages? Are these swarms different? And then if we continue, we see here is a limit between the Taudani Basin and the Birimian basement. And now we do see these two dikes, that they just disappear on the cover. So we have an idea that these are probably older than the Taudani Basin, so probably pre-1,000 million years approximately. And then we do see other generation of dikes that clearly cross-cut the Taudeni Basin, so they must be younger, and we do see them also in the basement. So here is another example from more to the south, where we see them very well. So these are the northeast ones, which are post-Taudeni Basin, and these are pre-Taudeni Basin. And then we have another pattern within Taudeni Basin, these curved dikes or signal. It's highly magnetic signal, which turns out to be in the field to be the sills. And these sills were already present in the 2003 map. So they have mapped these sills as these green bodies, but they didn't see these northwest trending dikes. They were not mapped in this 2003 map. What is important is the resolution of the magnetic data. Here are the regional data for Burkina Faso, where we do not see any dikes, and we have the same area thanks to the mining company Volta Resources at that time, high resolution survey at 20 meters, and we do see these northwest dikes. And what's really interesting, can you see here this zone? So it was interpreted as a fault, and it's completely parallel to the dikes. So we can understand, thanks to these observations, that the dikes at some places, they follow actually the pre-existing structures. And when we have this in mind, we have seen this also at other places, even with the regional data, when it's less obvious, but we have seen this behavior too. This is the example of Côte d'Ivoire, and we have again the regional magnetic data. We do not see the dikes at all. Here is just one small dike, but in the old map from 70s, the dikes are actually mapped. So this is how we have understood that they must crop out somewhere. So when we went to the field, we have found actually some outcrops. So this is an example of an outcrop of a dike, which we call then San Pedro swarm, and it was dated. I will show you the age later. So by this approach, so using a combination of regional magnetic data and old geological maps, we could cover quite an important area of the West African Craton and classify at that time the dikes into different families, just called by letters at that time. And we can see that there's actually all orientations possible. So it was published in 2015, and since then we have started to study these dikes more in detail. So we looked at petrography and geochemistry. So this is an example of dike which actually has a gabbro texture. You can see here the strong magnetic susceptibility too, so that's why we can recognize them very well in the field. If we have a doubt, quite often they are very strongly magnetic. And in Burkina Faso, we can see very well the trend. In Ghana, we do not see very well the trend, but we have anyway found some nice outcrops which are in situ. So for the paleomagnetic study, it was really perfect. This is an example from Burkina Faso where we could sample a dike in a mine. It was a mine of Teparco, where we could also see very well the contact with the host rock. The same type of outcrop is in Niger, in Liberia, but unfortunately we couldn't do for the moment paleo paleomagnetic study because it was just too dangerous. And this is another type of outcrop. That's the sill, which is overlying a flat-lying sediment of the Taudeni Basin. So here are some pictures from the paleomagnetic studies that we've done in Manso Swarm in Ghana and in the Essakan Swarm in Burkina Faso. You can see how it's very well aligned with the holes here, and most of these rocks turn out to be in situ, which is really good. They haven't moved a lot. In terms of mineralogy, most of these dikes, they are composed of pyroxenes, so clinopyroxene, orthopyroxene, and plagioclase, and some of the samples, they also contain olivine. Then the iron titanium oxides, and some of them, they contain some secondary minerals like biotite, hornblende, sericite, etc. So this is the complete mineralogy of an example of the Manso Swarm. So it contains clinopyroxene, orthopyroxene, no, just clinopyroxene, sorry, olivine, plagioclase, some quartz, very limited, then ilmenite, magnetite, secondary biotite, chloride, sericite. And it also contains accessory apatite, badellite, which allowed us to date these rocks and also compare the two ages, the apatite UPB and badellite UPB, which is really good. It's a good control. So this is the southern part of the West African Craton, which we have studied in more detail. And I will come to the ages in further diagrams. What I just wanted to show you is that each orientation of each swarm has its orientation and color, which the color coding will be used in the geochemical plots that I will just show in the next slides. So you can see like each color corresponds to a swarm, to a trend. And we have also studied one sample, we have dated one sample, which is from Kaiser in Amazonian Craton. So yeah, the composition of pyroxene is quite variable. They vary from clinopyroxene sometimes to orthopyroxenes. These are the older, the Essakan, Cosimoro, and Liberi dikes. So they are about 1,790 to 1,520 million years. And these are the younger camp, about 200 million years. So you can see there are some differences of compositions, but still you can see the augite, pigeonite, and some orthopyroxenes too. And the feldspar, it also shows quite a high variability of compositions. In terms of bulk rock composition, we do see some variations between the swarms. So here's the color code, as I said, shown in the map. So each swarm has its color. You can see that most of these rocks, they are just they are all tholeiitic series. Most of them are basalts, andesite, basaltic andesite, and the Manso swarm, they are at the limit with the alkali basalt field. In terms of major elements, you can see also some significant differences between the swarms. For example, the Manso swarms, they are relatively rich in alkalis, or in titanium, relatively low calcium, while, for example, these blue ones, they are camp, so they have relatively low values in alkalis, and on the other hand, relatively higher amounts of calcium or magnesium. In spider plots, you can also see quite important differences. The Manso swarm, for example, doesn't have negative niobium tantalum anomalies, while most of the other samples they do. There is also San Pedro, which doesn't have this negative niobium tantalum anomaly. And another sample is the Corsimoro swarm, which doesn't have it either. Just to remind you, it's really interesting. So the pink one, it was the northwest swarm in Burkina Faso, and the turquoise one, it was the west-north one in Burkina Faso. So they look relatively similar in the field. There is quite a low difference in their orientation, but in terms of geochemistry, they are completely different. And I will show you later, but the ages are actually quite similar to the Essakane swarm was dated in 1525 and the Corsimoro 1575. So this was really surprising that in terms of age, they are similar, but geochemically completely different. And on the other hand, you have dyke swarms, which are in terms of age completely different. So these blue camp dykes, but very similar to the Essakane swarm. You can see they both have negative niobium anomaly. They have high positive lead anomalies, the pink and the blue. So that's the Essakane and Camp swarm. And again, you can see the differences. For example, the Manso swarm is quite different. It's also relatively more enriched in these trace elements compared to the other dykes. And again, the compositional differences, they come out in other types of plots too. So for example, the titanium versus vanadium, they show different ratios for different swarms. You can see they are, some of them are more alkali trend, some of them are less. And for example, the Manso swarm, they are very rich in zircon and titanium, while the other samples are not. What's really interesting here is the San Pedro swarm, which is about 182 million years old. Compared to the Camp, it's different, but relatively similar. But in terms of geochemistry, it's very different. It's not at all the same swarm or source as the Camp. So this is really interesting. There is another example of a plot where we do see different trends. So this is the mixing line between the N-Morb and upper continental crust. So again, you can see different groups of points of data. And finally, for even the metals like nickel or copper, they show different amount of enrichment. For example, the Essakane swarms, they are very rich in nickel, or some of the samples, actually, not all of them. This is interesting that you have samples in Essakane swarm which are really poor, and some of them are rich. And then the Manso swarm, for example, it's very poor. And finally, if we plot the data in the niobium versus ytterbium and thorium versus ytterbium, we can see that some of the samples, they show more like crustal contamination, for example, Essakane, but also the Camp samples. And the others, they have more source enrichment characteristics, like the Manso or the Kédougou swarm in Senegal. So as I have said, we have dated these samples. So we have used two different techniques. So one was UPB on Badelei, and on some of the samples, on the samples from Ghana, Paul Antonio, he used also the UPB technique on apatite. And fortunately, the ages are relatively very well correlated. They, within the error, they are the same. So we were really happy about that. And if I put you all the ages that we could obtain by now, we have, so the oldest age is the 1791, it's the Liberi swarm. It's a north-south oriented dyke. We can see very well this swarm in the mine of Liberi. But as you see in the data, it's basically the only place where we do see this swarm cropping out. Otherwise, we just couldn't map it. It could be because of the quality of the data and the low magnetic properties, or because of something different that we do not understand. But as I will show you later, this swarm is regionally very significant and can be correlated very well with dikes of this age in South America. So it's really huge. The second age is 1764 in Senegal. You will notice the age is relatively similar, but the orientation is not similar at all. These dikes are oriented northeast. Then we have the Cosimoro swarm. So I have already mentioned this, 1575. So the trend is at some places quite similar, a little bit different, but quite similar to the Essakan swarm. You see here, 1523. The Essakan swarm, unlike Liberi, can be found at many places of the Craton. So we could find it in northern Burkina, southern Burkina, and then also in Ghana. And we have actually found the same age in Senegal too, Sambara-Bougou. And this dyke swarm is oriented east-west, so same age, but different orientation again. Then we continue, we have found 1915 age in Oda, so it's this northeast trending orange swarm. North-south oriented Manso swarm. You can see that actually the orientation is the same as Liberi, but the age is not at all the same. So all this is very, it makes it quite difficult to map these dikes, to make sure about which swarm they belong to without the precise ages. Actually, we can't just say north-south is this swarm or that swarm, because you can see it just has 867 in southern Ghana, 1791 in Niger. And finally, the last type, or the last family, no, sorry, not the last, but one of the most important is the camp. So we can see either the dikes, this is the northeast trending swarm, and these sills, they belong to this family too. And the last one is the 182 San Pedro in South Côte d'Ivoire. And as I have said, geochemically, it seems to be very different from the camp. And in future, we are planning to look more closer to this one. So these ages were used in the age barcode method they were correlated with other cratons. And what we can see is these yellow lines are where we have our ages in southern West African craton. And what we see is a correlation of the Kedugu Liberi with Avanavero in Amazonia. So that's really huge swarm. It also corresponds to Prutivka AMCG in Baltica. And there are also some other, there's the Congo, San Francisco, and North China that also have this age record. The Essakan swarm 1520 is very well correlated with the Kaiser in Amazonia Craton, and then the Oda and Manso can be correlated with the Congo San Francisco Craton and with the North China Craton. So we have concentrated mostly on this 1790, 70, 60 events. So this is some rather sketchy reconstruction. To be more precise, it would really need some paleomagnetic data. But anyway, based on the orientation of these dikes, we could just trace them. So this is Libiri, this is Kédougou in Senegal, and there are, this is the Avanavero, and I just can't remember what is UNV in South America. And there are also these dikes of this age in Tagragra Craton. So all these orientations, they give the center, potential center about here in Algeria. So that would be the potential emplacement center. And the second swarm, it's the 1520 Essakan swarm and Kaiser swarm in South America, which could be correlated this way. And then we have used actually the CAM event from Jourdan et al. From this paper at 2009, and we have drawn his plume center of the camp dikes. And what's really interesting, that his camp dikes, they are drawn to be at this orientation, which corresponds to present day northwest orientation in Côte d'Ivoire. So there are two things. Our camp ages in Burkina Faso, they have northeast orientation. So this is perpendicular to this orientation from Jourdan. It corresponds to the Kakulima trend of the Kakulima intrusion in Guinea, and also to the trend of the U and T dikes in South America. And second thing, which is interesting, that this northeast dike, which is attributed to the camp by Jourdan, we have actually dated it at 182. That's the San Pedro orientation. And for the moment, we only have this one sample dated and the geochemistry of this point. So we can't do really big conclusions, but it's surely a place where we should continue the future research to understand much better what happened actually during the camp and the Karoo events. So talking about the paleogeography, so classically in many papers we consider that Amazonia and West Africa were together at approximately 2 billion years, and they were connected during the Hibernian trans-Amazonian orogeny, and now the question is to test this connection. So at 2 billion years, using this model, the poles they cover relatively well, but at 1.8 billion years, actually, there is some difference already between the poles of West Africa and Amazonia Craton. Recently, Chardon et al. He published a paper which was actually based on the interpretation of structural data. So he correlated shear zones across the West African and Amazonia Craton, and he had some different ideas, and he suggests a counterclockwise rotation of about 20 degrees with respect to the previous model. And this rotation would actually explain relatively well the position of the West Africa and Amazonia Craton at approximately 1.8 billion years. So, and knowing that actually the data, there are only few data in West Africa for the paleomagnetic reconstruction, and in Amazonia for that period there are not many data too. So that's really a research project for future that should be done. And we have studied more in detail the monster swarm in Ghana, which I will present to you a bit more detail. So this is the north-south swarm. We could sample it across this area, so relatively good sampling coverage. And we could obtain, so it's the work of Paul Antonio, and he could obtain the first neoproterozoic key pole for the West African Craton, so for the 860 million years. And if we look at the reconstruction, we see a single apparent polar wonder path between 1.2 billion years and approximately 860 million years for these cratons. So there was Baltica, Amazonia, West Africa, San Francisco, and Congo. So that's why we call it the new super craton, which is the Wabango. So West Africa, Baltica, Amazonia, Congo, between this 1,200 and 860 million years. So this is the path, and we suggest that the implications for the assembly of the Rodinia continent are following: that we have the closure of the Nuna and Grenville oceans and collision of Laurentia and the Wabango block from the south, and then it formed the Rodinia supercontinent about 860 million years. But actually, to confirm this, we need much more data for the Amazonia and San Francisco Craton to test the different models. And this is actually a postdoc of Paul Antonio, so he would probably say more detail about it. But actually, he had studied the dikes, the Maquinet swarm in French Guyana, and actually it was really good luck, because the age, it really corresponds to the Manso dike swarm. It's 850 million years, and he could do the preliminary poll, and it's a work in progress. So it's really promising. And then we have done paleomagnetic sampling and modeling in Burkina Faso. So there are two different swarms. We have obtained the first results for the Esseken swarm, which is 15-20 million years old, and then for the Camp Sils, so that's the study. And here it's plotted on the plot of Nomaid et al. 2003. So it plots close to the Guinea too. So to conclude, there are several swarms in the West African Craton that reach over 1,000 kilometers. And some of them, they can be successfully used for the barcode reconstruction method. The swarms of different ages may have a slightly different orientation at the Carleton scale. So for example, the Manso, which is 860, and Liberi swarm, which is 1790. So they have the same orientations, completely different ages. And on the other hand, one swarm of the same age may have two different orientations at the Carleton scale. So this is the example of Essakan Sambarabugu swarms at 1520. And even dyke swarms, which are not well expressed in magnetic data, may be of crucial importance and size. So it's, for example, the Liberi swarm. And significant geochemical differences between the dykes were found, actually. So they are related to the source composition, the mantle composition at that time, at the time of the emplacement, but also to the petrographic processes. And many of the dykes, they have subduction-related geochemical characteristics, so negative niobium anomalies, but which is really not possible because at that time of the emplacement of the dykes, there was no subduction close to Burkina Faso, for example. So this is there is probably some inheritance from the source in terms of geochemical composition. And the paleomagnetic reconstructions, we could successfully do them on several dyke swarms, and we hope to continue in future. So, for example, we have the poles for the dykes at 1520, at 860, and 200 million years. And I will just mention briefly the future work. So as I have said, we will surely extend the study of the San Pedro swarm in southwest Côte d'Ivoire. We question the link with the Toarcian ocean anoxic event, which took place in the literature. It's mentioned 183 million years. So that's really close to this big event. And also there is a probable Karoo connection. This is the same age as Karoo. Now the question is if there was really a physical connection of this swarm, if the dykes are really that long or that huge, or if several magmatic events took place at the same time, but at very different places of the globe. And in Northwest Ivory Coast, we have some brand new samples that we have just sampled like 1 or 2 months ago. So we have not done anything on them, but we will surely look at them. And some of the outcrops are in situ, so good candidates to do some paleomagnetic study too. Then there is a PhD student, Laura Gampo, working in Niger. He has found on top of the Liberi swarm that I have already described, he has 2 more or 3 more swarms. So one is probably Essakan, but he surely has at least 1 or 2 more new swarms, which I have not described in this study. So that's really exciting, and it's an ongoing project. And finally, there's PhD student Michael Boame, who is working in Ghana. So hopefully he will have some new data from the buoy belt. You can see here a big concentration of dykes of different orientations. For example, these east-west dykes, which we have not studied yet. Or there are some west, northwest, east, southeast. It's not sure if it's continuation of Cosimuro or what they are. And also he will do more sampling of the other dykes in south. So thank you very much for your attention.
Thanks a bunch, Lenka. That was great. Before we get on to our question set and discussion session of this, I've received some intel on next week's talk from Margaret Lantink. It's going to be titled Milankovitch Cycles in 2.44 billion year old iron formations. Insights into the early Earth and Earth-Moon system. So that's just a bit of info for next week. But let's go ahead and move on to question and discussion. The way we do that here is you can either raise your hand virtually. So find that along the bottom of your Zoom window. If you go over to reactions, which is to the right of the share screen, and you click reactions, at the very bottom of that pop-up is raise hand. So you can do that, or you can type it into the chat and I can ask it for you. Okay, we have a question from Ake Johnson. Go ahead.
Okay, thank you. Thanks a lot for your presentation. It was very interesting to hear. I was thinking about this Manso swarm in Ghana, that it strikes perpendicular to the coast, so it should have a continue in Amazonia. And it seems that now that Paulo Antonio has found it in French Guiana. Almost the same.
Yeah.
So that would be interesting to follow up, because then you really have a very exact point where they should fit together. It would fit very well with the Sauri Carleton then being just outside of Suriname, then as I did in my Samba reconstruction. So then you can use it like a jigsaw puzzle and really put them together, and fits very well. So that was very interesting to see.
Yeah, he was very lucky to find exactly the same age. Really, it's so incredible. Like when you see how many different ages finally we have found. He was really lucky, and it's he should have the results published soon, I hope.
I don't know if you have seen, but I commented on your recent, or and a lot of other people's recent paper in Gondwana Research. I had some discussion by email with him and about the reconstructions and how to fit West Africa relative to Amazonia and how when it moves. I don't know if he had shared that discussion with you. Otherwise, you can ask him.
Not everything. No. But maybe you can recall it here. What you have discussed. It's
well, one was that sort of a more exact fitting. I mean, the paleomagnetics that gives a kind of rough, but there's always, you can move around quite a lot, even with these big arrow ellipses. So I think a more exact fit, if you can do that with say Sauli Carleton outboard of Suriname and this Manso, and so you can fit West Africa and Amazonia more tied together. And then as I see it, sometime after 860, sometime in the Neoproterozoic, there was like 1,500 kilometers of relative movement that is related to this rockylide orogeny in Liberia and the what's called Guapuri or something in south of Sauli Carleton. So that was when West Africa moved kind of east in present day coordinates to go into the Gondwana configuration. That must have happened sometime in the Neoproterozoic. So.
Yeah. It's younger. Yeah, for sure. Thank you.
Okay. Yeah. Thanks.
Thank you.
Okay. I think Richard is interested to discuss next. So go ahead.
Thanks, Lenka. That was great, and it's great to see the continuation of building on what we did as a great collaboration with WAXI and the Geocron, from our Large Igneous Province Industry Consortium project. It's just amazing the way the incredible size of these different swarms, and that coupled with the chemistry and the continuing work of Urugumbo and Michael Bohm, etc. So it's so exciting to see it's coming into focus. And one of the things that is still to be sorted out is trying to figure out where some of these huge swarms start from. Potential plume centers. These are Mackenzie scale swarms. So, but one of the things I wanted to mention is early on you mentioned I forget which swarm it was, along dyke, and then parallel to it a fault that was similar.
Yes.
And you mentioned the idea of the dyke taking advantage of a pre-existing fault. One other possibility, and I think this is the one that I think may be more applicable, is that in some ways what happens is potentially if it's part of a big radiating swarm, broad domal uplift, radial fracturing gets produced from the domal uplift, and then the particular fractures get filled based on magma availability. So in such an area, you could have, yes, you know, the fractures that are filled are most prominent and represent, you know, obvious dikes. But some of the other unfilled ones may in fact still in some ways be visible, but have been fractures that were produced during the same event, just in the initial stage of uplift. So it's something that I think we can think about, because there's been oftentimes this debate about dikes filling pre-existing fractures, but in some cases it's sort of both things are true. The domal uplift perhaps producing a radial fracture pattern, and then the availability of the magma filling most, but maybe not all of the pre-existing fractures.
Sure. Yeah, sure. And that's really a good point, because we do have a problem to date actually the faults in West African Carleton. Like we see they displace the Paleoproterozoic basement rocks, but we do not know if they are like late Eburnean, or if they could be like whatever either during the dikes swarm emplacement, or if they are even younger. Like we don't have any mean to date them for the moment. It's so it's a possibility actually that that the faults developed when the dikes were in place. It's surely one of the options. Yeah.
One of the areas that kind of shows this as an example, and could kind of be cited as examples associated with the Columbia River lip event in northwestern US, where the Columbia River dikes are certainly have a original radiating pattern, but off to the east there are some fractures that have been filled by available hydrocarbons. So gilsonite dikes, they're called. Paper by I think it's Jim Sears talks about their radial trend, and they're not filled with Columbia lip magma, but they are overall radial to the same center as the Columbia River dikes, and then they're recognized in some cases by being filled with hydrocarbons. That is, the fractures produced, it sort of, I guess, sort of pressure release from the underlying hydrocarbon-rich formations, and it fills into that. So anyway, it's an idea that I think we will find more.
Yeah, why not? It's possible actually, because I have also noticed that there are some places that we could see even Pan-African structures, and it's the same, we can't really date them. But my idea comes from the fact actually that the Tau Deni basin sediments are at some places strongly deformed. So if the Tau Deni sediments covering the basement are strongly folded and unfaulted, then what was the response or the answer of the basement? So surely it was deformed too, but we are unable actually to distinguish this deformation, which it was probably not very strong. It was not probably ductile, just some faulting probably, and this is really difficult to date. But for example, near Esseken, in Burkina Faso, I have seen this deformation in Tau Deni, and I went there really on purpose to see that, because in the old maps they just drawn some folding. So I really wanted to see that, and indeed that's folded. So there's surely some post-Eburnean deformation in the Carleton, and it was not really systematically studied, and to be honest, we have for the moment no idea how it is expressed and when it happened actually. So yeah, possibly part of it could be related to the emplacement of the dikes too.
Okay, we have a couple more questions in the chat now. Adengra Martial asks why they're wondering why are the nickel concentrations so different, and sorry if I'm mispronouncing, I forget how you pronounce it, in the Esseken samples?
Okay. Well, it's probably related to the source composition, I would say. It comes directly from the mantle, and yeah, either it's enriched or not. It would probably be the source. And I see the other question is if there is a link between the grain size of the dikes and their orientations. So it's not a direct link, but we have noticed, for example, that the older dikes, they usually have bigger grains, so they are more like gabbros. So for example, the Essakan swarm, they are usually gabbros, Sambarabugu, they are gabbros, while the Camp dikes, they have much finer grains. So potentially it's because they were in place maybe like at shallower levels or something like this. I don't know, or they cooled quicker at that time. But on the other hand, we have found higher grain size in the sills and in the lava flows in Côte d'Ivoire and in Burkina. So it's not straightforward. Yep. And also, of course, if you have a contact of the dike with the host rock, then you have the chilled margin, and then you decrease the grain size too. And yes, surely it's also the thickness of the dike, because the dike, one of the sample actually of the Manso, we have found it in the mine, in Ahafo mine, and it was relatively thin. It was maybe a couple of meters, very fine grained, but at other places, the Manso dikes, they are coarse grain gabbros. So you have a complex relationship, and I wouldn't really say it's related. Yeah, Go is from Congo. It's Paul. Paul is there. Oh, he can reply to some of the questions. Yeah, so it's not really related to the orientation. I would really say it's more like the thickness, the depth of intrusion, the distance from the contact of the host rock. Yeah.
Okay, I think David Evans has a question. David, go ahead and unmute yourself.
Thanks.
Yes.
Hi, excellent presentation, Lenka. Thank you. I'm really pleased to see this work continuing in full force and with excellent results, and also to Paul, who's able to join us. So thank you and congratulations. My question was about that particular, whether to include Congo in Wabango, or whether we should have a no-go and just have Wabam, which is very similar to Samba. If you get my drift. Pardon the pun. So I wonder if we could see that figure of Wabango.
Yeah, I can just try to put it back. Do you mean this one?
Yeah, perfect. That's exactly
Yeah.
the one. So yeah, I think there's a lot of excellent evidence in support of some sort of version of Samba, which is Baltica, Amazonia, and then with or without West Africa. And you guys have done an excellent job of adding West African data to Samba and confirming that to first order. My question is about whether we want to include Congo in this, because at 1100 million years, we, as you've shown in the paper, we do have constraints from Congo. This is Johannes Salmonen's paper, but with Kalahari, and the figure that you had in the Antonio et al. Paper actually had the preferred reconstruction of Kalahari was the opposite polarity, which was the same as Salmonen, which is just sort of to the southeast of Congo in this figure. But if in that polarity option, then Kalahari would have to swing all the way around and spin around 180 degrees to get from Wabango to its position in Rodinia. The alternative that I'm favoring is whether Congo, instead of the polarity option, you show it at the 1110 reconstruction, if you actually swing that polarity option around and have it join Kalahari on the other side. So just wanted to hear your or Paul's comments on these degrees of freedom, and how much do you really want or need Congo San Francisco to be part of this assemblage?
Yeah, Paul, are you around? Can
Yes,
you hear
I'm
us?
here. I'm here. That's a really good question, David. But it depends on the polarity, and we don't have a lot of data for Congo. That's true problem. And for now, really we don't know exactly. So we have this kind of two options. So we can't play with that. And I would like maybe in the next year if we can obtain some data of maybe younger, just to be sure about that. I think it would be nice, because the problem is the same for Kalahari. We don't have data for during the Neoproterozoic, so it's really difficult to play with Kalahari and Congo. And so maybe it's next year if we can obtain some new data for Kalahari and Congo, maybe we can be sure about the orientation of these two craters. But really, it's a good question. We don't know, and it's like the same question about the tide fit between West Africa and Baltica of Ake. We were talking about that by email, but maybe with these younger poles, for example, for Amazonas that I'm calculating, maybe I can calculate if this kind of tide fit between Amazonia, West Africa, and Baltica is possible. Because it's just geological reconstruction for now. So let's see. Maybe let's see in the future if we have new data. But for now, it's complicated to be sure about this kind of reconstruction.
Yeah, thank you. And for this sounds like quite a detail, but I think in general terms, I think this question of interpreting polarity is really interesting in terms of whether we think that one supercontinent goes to another in large scale reorientations, or just with sort of minor reshuffling. That's the kind of extroversion introversion question. So I hope that this will be of interest to the broader group as well.
Okay.
If we don't have questions, maybe I have a couple.
There is a comment from Ake.
Yeah.
I agree. Yeah, maybe let's read it to everybody.
Yeah, I was just looking at it. Aki Johansson said he agrees that it would be more sensible to have Kalahari and Congo on the other side, or the western side, so they can go more easily make it where they are supposed to be in Rodinia.
Yeah, I think you have to think about not just what the situation is at 1110 or so, but where are they supposed to end up in a Rodinia reconstruction? And it seems difficult for Congo to make it all the way around to, if Congo and Kalahari are to be somewhere to the southwest of Laurentia.
Yeah, so I think
I agree with David Evans about that.
So let's just turn it into open discussion now rather than question and answer. So feel free to speak up and discuss. Sorry to cut you off.
Yeah.
Could I jump in then? Oh, Andre, you're gonna?
Yeah, maybe.
I just had one follow-up question on this sort of diagram here on the reconstruction.
Yeah, go ahead.
Just so in the reconstruction, the Manso dikes, which are north-south trending, right? They're potentially the same trend as the similar age dikes that have been dated and studied by Nasser Yubi's students, as you see on the north in West Africa from south to north. And so, we've wondered about the possibility of there actually being a continuous swarm from 860 swarm from south to north across the West African Craton, some 2,000 kilometers. And like I was just wondering if there's any new insights into whether the Manso swarm can be more specifically traced further north of where we can see it now, to sort of towards answering the question of the potential of a continuous swarm north-south across the West African Craton.
But it could be, we just don't see it in the data, but it doesn't mean that it's not there, like you see with Liberi. So it could just disappear and appear in Morocco if this is the same age. You see the orientation, we can't really rely on it 100%, but probably the age, if this is the same age, it could be. And also we could compare the geochemistry, the composition of the rocks, etc., to make sure. But I think it's possible, like what we have seen from the other swarms, they do not continue at all throughout all the Carleton. They just appear, disappear. Even the second swarm, actually, there are parts it disappears and then it appears in Senegal. So
Right. Are they covered by the Tawadeni Basin in part to there? I forget the specific geology or the.
Yes, partially they are covered by the Tawadeni Basin, and partially actually there is Mali, and we do not know really how they look like in Mali, or if they are cropping out. For the moment, it's not clear. Yeah.
To be continued.
Yeah, surely the Tawadeni Basin, it must cover the Manso. Yeah.
Well, the Tawadeni Basin is it's a billion-year-old sediments, right?
It's billion-year, but you have some younger, actually, you have, I think, some younger layers which are younger than that, I think. So the oldest parts, no, they are older than Manso, but there are some younger parts that are a bit younger, I think. Yeah. I think it goes to Cretaceous, even something like this. Like they're very young layers. Yeah.
So Lenka, a couple of questions for Essakane and Sambarabago dikes. Do you mention them as sort of the same plume event, or is it like we have different orientations? So, but I didn't get if in geochemistry they're similar or different. Or
they are quite similar. Yeah, I would say this one is quite similar because the ages is very short period. It's like 1520 to 1522. So this is very, very short. And just find a couple of plots. But so the Sambarabugu is this, we don't have that many samples from Sambarabugu, but it falls into the group of Essakane. They are triangles. This is the darker triangle, and look at that. It falls really within the group of Essakane. In other plots, yeah, it's here. So yeah, let's say you can connect it with Essakane here, similar to Essakane. Yeah, that like the Essakane itself is quite variable. You see the Essakane swarm, it has quite variable geochemistry on itself. Like across the Burkina to Ghana, you have very, very high variations. Yeah, I think here the Sambarabugu it's similar too. So it just doesn't show up. And here it just falls into the group. So it's probably the same event. Yeah, I would say. Like,
and
could I just add something on Andre on that comment on that question, your question?
Yeah.
Just that the difference in, so this is not unusual, right, for a swarm to swing in trend. The Mackenzie swarm, is radiating on a huge scale, out to beyond 1,000 kilometers, and then it swings into a common trend. And so that kind of swing could mean whichever end we end up choosing, if there's a plume head radiating swarm at one end or the other, that transition in trend could mean, that transition.
But in this case, we occur in the same place.
Yeah.
Well, no, they're on opposite sides of the Crawley.
I think on the figure we were in the same place on the west end.
No, they're on different sides of the Crawley, right? We go to.
They're on different sides. Look at that. This is the example of Mackenzie. You see the distance, and at quite a high distance, you can have some misorientation. And if you look at the map, I will just find the map. Where is it? Yeah, it's this one. So this is Sambra Bugu, and a second, it's not,
Okay.
yeah, it's something 1,000 kilometers, 1,500 kilometers. Yeah, so it
So
could,
that's,
yeah.
Yeah.
It
so that's a
could
30-degree trend or 20-degree
yeah,
switch.
yeah. That's a 30-degree. Yeah. So and I don't
So it could
know
be seen as
actually.
more-
It could be present here in Mali, like these east-west trends too. I don't know. We haven't dated them yet. I don't know. I don't know really.
And a second question, 860 event. Do you see anywhere in West Africa evidence for rifting at the same time? I guess maybe in Morocco, but anywhere else?
Rifting, like extension, not really.
Like initiation of a basin and
No. Not really. No. Not in the Carleton. I'm just thinking about, but even the floods. Actually, we have found some floods here in Côte d'Ivoire during the last trips, and they do not seem to be related to rifting. They just cover the basement. You know, they just are sitting on the top of the basement, but we do not see any normal falls related to that whatsoever. Yeah.
thank you.
So yeah, some fractures probably just open. Yeah.
Okay, well, it seems like discussion is content. Thanks a bunch, Lenka. Really good presentation.
And there's
Thanks
yeah,
everybody
thank
for
you. And there's a question from Ake to David Evans. What about you?
Oh, I
and
missed those. Okay.
Goings? Yeah, just
Yeah,
curious.
I just posted
Sorry.
it. So it was not for Lenka, it was more for David Evans. I was thinking about his 180 degrees flip of West Africa around in, was it
Oh,
2021?
sure, that
With the
discussion
Chinese guy.
continue.
So I don't know if we should take it up there. If you want
I'll
to
just
comment
say
on that.
quickly because this is not my my day, but in the spotlight. But just quickly, yeah, that there are quite a few predictions there that this 1525 poll when it comes out will be really interesting. From when I was scrambling to take notes, it looked like that poll, there's a lot of scatter to that poll, so it's kind of hard to assess. But yeah, hopefully time will tell.
Yeah.
We'll see.
All right, good note to end on. Again, thanks to Lenka and thanks everybody.
Inshallah.
And we'll see you all in future seminars.
Thank you very much. Yeah, thank you to everybody for listening.
Thank you,
Yes.
Lenka and Paul.
Thank
Very
you.
great
Bye.
presentation, Lenka.
Very great,
Yeah.
Lincoln Paul.
Thanks.